So our final curve sketching problem, we're looking at f of x equals 2 over x minus 1, and we're given that the end behavior as x goes to negative infinity is going to 0, which makes sense because this function itself is bottom heavy, so the limits as x tend to infinity should be 0. So that just tells me as I go out to the left, as x goes to negative infinity, the direction is left. As I go to the left, my y value should stop at 0. And as I go out to positive infinity in the x value, remember we're talking about x, so we're not saying as we're going up. If x is going to infinity, we're going to the right. Our y value is going to stop at 0. So maybe we'll just throw in a couple arrows. So as we go to the left, we want to remember to stop at 0. Just maybe give ourselves a couple dots. And as we go to the right, we're going to stop at 0. So we're going to approach 0 on the left and the right because we have something bottom heavy. The next thing we're given is that we get a horizontal asymptote out of that at y equals 0, which is the same thing as the limit at infinity. So we knew that our horizontal asymptote was going to be at 0. But we also have a vertical asymptote at x equals 1, which makes sense because a vertical asymptote was something that made us divide by 0. We remember this from test 1. A vertical asymptote makes you divide by 0, and it can never cancel out. So that makes sense here. At x equals 1, we'd be dividing by 0, and we can't cancel that factor out. So we have a vertical asymptote, and I'm just going to draw myself a dotted line. So remember that I have a vertical asymptote there. At x equals 1 is going to be this line here. So we'll just draw ourselves a dotted line all the way down for our vertical asymptote, something that makes you divide by 0 that can never be canceled out. So my next piece, if I'm looking down there, is about increasing and decreasing. So this is the sign of the first derivative, tells us whether we're increasing and decreasing. And I like to make this into a sign chart. I think it makes it a little bit less overwhelming. So we want to make a sign chart out of this that says it's never increasing, so it never has a positive first derivative, so it's never rising. And it's decreasing from negative infinity to 1, union 1 to infinity. So we're going to put that on our sign chart. The critical number is the only thing that can go in these intervals for increasing and decreasing besides infinity. So our critical number is 1, and it's always decreasing. So we want something that's falling on both sides of 1. I just like making it into a sign chart. With that, because our critical number doesn't have any sign change, it goes from decreasing to decreasing, we see that we have no relative extrema points. So it's going to make plotting this a little bit harder. So far, I have no concrete points. I just have asymptotes, and I have that it's always decreasing. So harder than our last one. Next thing I'm given is the sign chart for the second derivative, concavity. It's concave up from 1 to infinity, and concave down from negative infinity to 1, rather. So if we plot that on here, and maybe we'll change our color for this since it's the second derivative. So we're going to put another sign chart, but this green one is the second derivative. I'm going to put my possible point of inflection on here. No other number can go in here unless it's a possible point of inflection. And we're concave up from 1 to infinity, so it's after 1. We're concave up, so the second derivative is positive, and before 1, we're concave down. So we go from being concave down to concave up, and that does give us a point of inflection. So why does it say there are none? Well, to be a point of inflection, you have to have a y value. So if we try to plug this in here, our point of inflection has an x value of 1, and our y value, we would plug into the function to find a y value. We'd have 2 over 1 minus 1. We'd have 2 over 0. So we're dividing by 0. That tells me we can't do it. It's not a point on the graph. So there is actually no point of inflection. So it passes all of our tests. It makes the second derivative 0. It has concavity change, but if it's not even a point on the graph, if it's undefined when you plug it in, then you can't plot it as a point of inflection. So the hard part about this one is I have no points. I have the general shape of the graph, but I don't know where to put it. So let's, off to the side here, get a general shape of our graph, and then we'll figure out where to plot it by figuring out just some random points to plug in. So before 1, my sign chart says that I'm decreasing and concave down. So let's use that concave down. We'll draw our 3 options. It's either a full U, it's the left side of the U, or it's the right side of the U. So I need to figure out which one's decreasing and concave down. So the first one is increasing to decreasing. The second one's always increasing, and the last one's always decreasing. So we're going to draw something like this before 1. This one is decreasing and concave down, matches both of my sign charts. That's what the left part of the graph is going to look like. To the right of our vertical asymptote, what we should put in this face here, has to be decreasing but concave up. So I'm going to draw my 3 options for concave up. So it's either a U, it's the left side of the U, or it's the right side of the U. And I have to figure out which one of these 3 is increasing. Well, this one's decreasing to increasing. This one's always decreasing, and then this one's always increasing. So I want to choose this third option. This is, just kidding, we want to be decreasing. We're going to choose the second option, decreasing and concave up. Always decreasing, but we want it to be concave up. So we're going to switch. We're going to look like this last piece here. So I want to plot these arrows bigger down here. I'm going to have this shape here, this concave down and decreasing. I want to put that right here. And I want to be concave up and decreasing and put that on the right side of 1. But I don't really know where to plot them unless I plot some points. So I just need to choose literally any random point I want to see where I can kind of like center these pieces here. So I can plot, again, any point I want to. I can choose any x value. So maybe to figure out where this left side is, I'm going to plug in, say, -1 and 0 into the equation and see what the y values are at. So I'm going to plug in just a couple random points. I'm going to do -1, and we're plugging into the original function, which is 2 over x minus 1. So we're going to do 2 over -1 minus 1. So we'll have 2 divided by -2. So the y value with the -1 is -1. So I have 1 point. I know not to draw this big piece above the graph here. The point is -1, comma -1. Maybe I'll plot another point to just see where I am. I'll plug in 0. So I'm going to have 2 over 0 minus 1 plugging into the original. So we have 2 divided by -1, which is down at -2. So I can plot at 0, has a y value of -2. And now I just literally need to draw the same exact shape that's on the left side, that's decreasing and concave down, and put it in over here, which of course is going to be harder to do for me on my tablet than it is probably for you on paper. So this isn't going to be perfect, but I'm going to draw something that's definitely decreasing and concave down and goes through the points. And I also want to make sure I get in this horizontal asymptote here. It should be approaching 0 as we go off towards -infinity. So there's my first piece. It's decreasing, it's concave down, and as x goes to -infinity, our y value is going to 0. So I have that asymptote and that end behavior in there from above. So we go to -infinity. As we go to the left, we're stopping at 0. I have my horizontal asymptote. It's decreasing and concave down. So far I'm pretty good. The next part, I need to make it concave up and decreasing. So I need to have this shape here, but I need to just make it bigger and put it where it's supposed to be. So maybe I'll plug in and see, am I above the x-axis? Am I below it? I'm just going to choose any random points I want to. And maybe on this side, I'll only plug in 1 point. You can plug in as many as you want to. Of course, the more you plug in, the more accurate your drawing is going to be because you'll have the more correct y values on there. But I'm just going to plug in 2. So the top at f of 2, we have 2 plugging into the original over 2 minus 1 in the denominator. So I have 2 over 1. So my y value is 2. So I have f of 2 is 2. And I can use that in my asymptote to draw this. So I should be approaching 0 as I go off to the right. So I'm just going to connect these pieces here and draw that same general shape that we have above on our sign chart for something decreasing and concave up and kind of connected so it's approaching my vertical asymptote as well. Again, a lot easier on paper, but As long as you get the general shape, you're approaching both of your asymptotes, so your vertical one and your horizontal one, and you have the same shape as above, concave up, but decreasing. Here is our sketch of the curve, and to make it more accurate, you can just plot more points.